Hi friends, my name is Milan Dholariya. In previous video, we learned up to the question number 6. So now in this video, we start with question number 7. Okay, so first of all, read this question. AB is a line segment and P is the midpoint. Okay, AB is line segment and P is midpoint. D and E are the points on the same side of AB such that angle BAD is equal to angle ABE and angle EPA is equal to DPB. Show that triangle DAP and EBP both are congruent. Okay, we need to prove that these two triangles are congruent triangles, and from that we need to show AD is equal to B. Okay, so AD is equal to B, that we can easily show by using this congruency criteria. Okay, so our first work is to prove these two triangles are congruent triangle. Now what are the given things for us? P is the midpoint, so definitely both this part are equal. AP is equal to PB, right? Because P is the midpoint of AB, so it divides the AB into two equal part, so AP is equal to PB. Other thing, that is angle BAD, that means this one angle BAD, and angle ABE, that means this angle. These two angles are same, right? Other than that, angle EPA, that means this angle EPA, and DPB, that means these angles are same. Okay, now we need to prove triangle APD is equals to EPB. Okay, now if we think about this two triangles, so AP is equals to PB, right? Because P is the midpoint. Okay, then angle BAD, that means this one angle, it is equal with the ABE, that means this angle. Okay, so these two angles are same. Here one sides are same and one angles are same. Now we want our third thing. Okay, but here it is given only up to this two angles are same. Now if we think about these two angles, okay, these two angles are same. If we add this part, in both this angle, so it becomes one angle of our triangle. Okay, that means what I want to say here, it is given that angle EPA is equal to DPB. Okay, add this common part, that means EPD on both the side. Okay, this is given to you. If EPA, if we add with the EPD, so it becomes full angle APD, and this is the one angle of triangle. Same thing here, this angle is given to you. If you add this same part, so this becomes the full angle EPB, and that is even one angle of triangle. Okay, so what we need to do, we need to add this common part to both this side. Okay, so here it is given angle EPA is equals to angle DPB. Now add this common part EPD on both the side. So adding angle EPD on both side, so we get, so now here we have EPA plus we need to add this part, so angle EPA plus angle EPD is equals to, here we have angle DPB, okay, plus we need to add this common part EPD. Okay, so DPB plus this common part EPD. Now if we add this common part on both the side, okay, so here EPA, that means this angle, plus EPD, so we can write full angle APD. So here it is addition of this two angle, it is angle APD. Same thing here, here we have angle DPB, right? If we add this part, so this becomes this full angle, so we can write EPB, otherwise BPE. Okay, here we have this part, and if we add this part, so it becomes full angle EPB, otherwise BPE. Okay, so give the equation number 1 here, that means this angle APD is equal with the angle EPB. Now again, just think about this two triangles. Here we have one triangle APD, and here we have one triangle P, here B, and here E. Now it is already given AP is equal to PB because P is the midpoint. right? If we can see the original figure, so AP is equals to PB. Now BAD, that means angle A is equal with the angle B. This is even given in the equation. And we prove that in equation 1, we prove that these two angles are even same. Okay. In equation 1, we prove that these two angles are same. So here angle, side, angle. Here even angle, side, angle. So by using angle, side, angle criteria, we can say that these two triangles are congruent triangle. Okay. By using the angle, side, angle criteria, we can say that these two angles are equal. Okay. So that we need to write here. So now in triangle APD and in triangle BPE, what are the equal things? So first of all, angle PAD, that means this angle is equal with the angle PBE, because it is already given in the equation, right? Angle BAD, that means angle A is equal to angle ABE, that means angle B. Okay, here it is given in the equation BAD is equal to ABE. It means angle A is equal with the angle B, so that we can write here. So angle PAD, this angle is equal with the angle PBE, this one angle. Okay, this is given in the equation. So angle PAD is equal to angle PBE. After that, second thing, it is AP is equal to PB. Why? Because it is given in the equation P is the midpoint of AB. So AP is equal to PB. And finally, from equation 1, we prove that APD is equal to angle BPE. So total three things we get here, right? These two angles are same, this one sides are same, and this angle is equal with this angle. So angle, side, angle criteria. Okay, so first of all, write down first triangle. Here we want a sequence DAP, right? So first of all, write down DAP. Now we need to arrange the second triangle. Now in DAP, angle A is equal with the angle B. So at middle position, we need to put B. Okay. Angle P is equal with the angle P. So at last position, we need to put P. And first position, we can put our third vertex EBP. Okay. So we get this sequence. So we can write triangle DAP congruent to triangle EBP. And which criteria we use here? By angle side angle congruency criteria. Okay, by angle side angle. Now if we prove this, then by angle side angle, right? So from that we can write AD, that means first and second things, it is equal with the first and second things BE. So AD is equal to B, and here we can write the reason by CPCT, that means corresponding parts of congruent triangles. Okay, if we prove this, then we can write angle if we prove this, then we can write AD is equal to B. Okay, first second with first second by CPCT, that means corresponding parts of congruent triangles. Okay, so here we need to use angle side angle criteria, and we can prove this, and from that by using the CPCT rule, we can prove this AD is equal to B. After that, question number 8. In right angle triangle ABC, in right triangle ABC, right angle at C, M is the midpoint of the hypotenuse of AB. Okay, M is the midpoint. C is joined to M and produced to a point D such that DM is equal to CM. Point D is joined to point B. See the figure and show that triangle AMC congruent to triangle BMD. Prove that triangle DBC is a right angle triangle. Prove that triangle DBC is congruent to ACB, and prove that CM is equal to half of AB. Okay. First of all, what are the things which is given to you? Triangle ABC is a right angle triangle, and here angle C is 90 degree. One more thing, M is a midpoint of AB. So these two parts are same. And it is also given that DM is equal to CM. Okay, so these two parts even same. So our first work is very easy, because here it is given that M is the midpoint of AB. So these two parts are same. DM is equal to CM, which is also given in the equation, and by using the vertically opposite angle property, we can prove that these two angles are same, right? So if we want to prove these two triangles are congruent, so here side angle side, by using the side angle side criteria, we can prove that these two triangles are congruent, right? Because these two parts are equal, M is midpoint, so these two parts are equal, and this is vertically opposite angle, so side angle side. So by using side angle side criteria, we can show that these two triangles are congruent. Okay, so in triangle AMC and in triangle BMD, AM is equals to BM. Why? Because it is given M is the midpoint of AB. Okay, angle AMC is equal to angle BMD. Both are equal because vertically opposite angles. And third thing, CM is equal to DM, which is given, right? So from that we can write triangle AMC. Now set up the congruency criteria. Okay, so here angle M is equal with the M. So at middle position we need to write A. Now AM is equal to BM. AM first second position. So first second position we need to write BM, and third thing C. So triangle AMC congruent to triangle AMC is congruent to triangle BMD. Okay, here C is not that, but here we need to write D, right? BMD triangle. So here triangle AMC congruent to triangle BMD, and criteria side angle side. Okay, side angle side. So we need to write this triangle AMC congruent to triangle BMD by SAS congruency criteria. Okay, done. And now we need to prove triangle DBC is a right angle triangle. Okay, but before that we need to prove something else, and that is by using this congruency criteria, we can say that angle ACM is equal to BDM, right? Because C it is last position and D it is even at last position. So both these angles are same. Okay, angle C is equal with the D. Okay, angle ACM is equal to angle BDM. Why? By using the CPCT criteria. Because we already proved that these two triangles are congruent. So by using the CPCT, we can say that angle ACM is equal to angle DBM, and other thing, that is angle A is even equal with the angle B. Okay, so by using the CPCT criteria, angle C is equal with the D, angle A is equal with the B. So these two angles are same and these two angles are same by using the CPCT, because we already proved that triangle AMC congruent to triangle BMD. Now if you look at here, then here it forms one Z, right? And we already proved that these two angles are same. So here we have the alternate interior angles property. If two lines are parallel, then these angles are same. And reverse property it is, if these two angles are same, then these two lines are parallel. So here we proved that, already proved that these two angles are same. So from that we can say that these two lines are parallel. Because original rule is, if these two lines are parallel, then these two angles are same. Reverse theorem, if two angles are same, then these two lines are parallel. So we need to use this reverse theorem here. Okay. For lines AC and DB and transversal DC, we have ACD is equal to BDC. We have ACD is equal to BDC. These two angles are same. Okay, it forms one Z. It means that these two lines are parallel. Okay, we already proved that these two angles are same. So we can say that these two lines are parallel. So angle, so AC parallel to DB. Okay, so AC and DB both are parallel lines. What is the reason? Alternate angles. Okay, because we what we prove here, alternate angles are same, so definitely these two lines are parallel. Okay, so we can write this BD parallel to AC. Okay, so that we write here AC parallel to DB. Here we need to prove that this is right angle triangle. Okay, DBC. So now what we prove here, these two lines are parallel. So now it is the concept of transversal. Okay, these two lines are parallel and this is one transversal. Sorry, these two lines are parallel and this is one transversal. Okay, two lines are parallel lines and we have one transversal. So these two angles are called interior pair of angles on same side of transversal. Okay, these are the interior pair of angles on the same side of transversal, and we know that sum of these two angles is equal to 180 degree. Okay, because we already learned this theorem in our previous chapter, lines and angles. Okay, if we have two parallel lines and we have one transversal, then these two angles is called interior pair of angles on the same side of transversal, and addition of these two angles is equal to 180 degree. Now if we rotate this figure, so here we have two parallel lines and one transversal, so these two angles are called interior pair of angles on the same side of transversal. So addition of these two angles is equal to 180 degree. Now we know that angle C is 90 degree because it is already given in the equation, right? Triangle ABC is a right angle triangle. So if this angle is 90 and addition is 180, so definitely our second angle it is even 90, and from that we can prove that DBC is a right angle triangle. So that things we need to write here. Now for parallel lines AC and DB and for transversal BC. Okay, consider this two parallel line and transversal BC. So addition of these two angles is equal to 180 degree. That means angle DBC plus ACB is equal to 180 degree. Okay, DBC that means this and ACB that means this. Addition of these two angles is equal to 180 degree. But it is already given in the equation. Triangle ABC is a right angle triangle and right angle at C. That means angle C is 90 degree. Right? So put this value here. So what we get here? Angle DBC plus this is 90 degree, right? So plus 90 is equal to 180. Now if you want to find the angle DBC, transfer this 90 to the right hand side. So angle DBC is equal to, here we have 180 plus 90 becomes minus 90 here. So 90 degree. So from here we can say that angle DBC is equal to 90 degree. Okay, angle DBC is equal to 90 degree. And if this is a 90 degree, so we can say that triangle DBC is a right angle triangle. Okay. So here we get this 90 degree. So we can say that angle DBC is a right angle. What property we use here? Again I repeat these things. These two lines are parallel. Addition of these two angles is 180 degree. Out of that one is 90 degree. So second one it is even 90 degree. And from that we can say that this is right angle. Okay. Now we need to prove these two triangles are congruent triangles. Okay. For that, here we have DBC and here we have triangle ABC. Now BC is common side. BC is common side, right? So it is equal. And second thing it is, here angle B is 90 degree, here angle C is 90 degree, right? Now we need to prove another things. It is DB is equal to AC. DB is equal to AC, and that things we can get from our first equation. Okay, first of all we prove that these two triangles are congruent. So from that, by using the simplicity we can prove this AC is equal to DB. So that things we can use here. Okay, again I repeat all the things here for this two triangle. BC is common side, both have 90 degree angle, and we can prove that AC is equal to DB. So by side angle side criteria we can say that these two triangles are congruent triangle. Okay, so in first question, from here write down AC is equal to BD. Okay, A and C first third position, B and D first third position. So these two sides are same, right, by simplicity. So we get here AC is equal to BD. Okay, BC is common side in both this triangle and one angle 90 degree. So side angle side criteria, by using that criteria we can say that triangle DBC congruent to triangle ACB. Okay, so that things we need to use here. DB is equal to AC, which is proved in question, proved in part 1. Both have one angle 90 degree and BC is a common side. Okay, so from that we can write this triangle DBC congruent to triangle ACB, and reason is side angle side criteria, congruency. Okay, so third question it is even done. Now finally fourth question, CM is equal to half of AB. CM is equal to half of AB. Okay, so how we can prove that CM is equal to half of AB? So that things we can write from here. Now we already proved that here DBC is equal to ACB. Okay, from that we can write DC is equal to AB. First third, first third. So by using this simplicity, we can write DC is equal to AB. Okay, because we already proved that these two triangles are congruent. So here first third position DC is equal with the first third position AB by simplicity. Okay, now DC means what? DM plus CM, right? Here DC means what? DM plus CM, it is full DC. Okay, so here DM plus CM is equal to AB. Okay, in place of DC, write down DM plus CM. Again, I repeat these things. Here we already proved these two triangles are congruent. So from that we can write DC is equal to AB. Okay, now in place of DC we can put DM plus CM. Okay, and AB as it is. It is already given in the equation DM and CM both are equal. Right? So in place of DM we can put CM because it is already given in the equation. DM is equal to CM. So in place of DM write down CM. Okay, now this CM as it is, AB as it is. Now here CM plus CM, it is 2CM is equal to AB. And if you want to find this CM, transfer this 2 to the right hand side, it goes to the denominator. So CM is equal to half of AB. Okay, again from this congruency criteria we can write DC is equal to AB. Now DC means what? DM plus CM, and it is already given in the equation. DM and CM both are equal. So in place of DM write down CM. So CM plus CM 2CM is equal to AB, and transfer this 2 to the right hand side. So CM is equal to half of AB. Okay, so students, first of all, these two sides are equal, this is are equal, it is already given in the equation, vertically opposite angles. So these two triangles are congruent triangle. From that, by using the CPST, these two angles are same and it forms one Z. It means these two lines are parallel. Okay, by using these two parallel lines and one transversal, we can say that addition of these two angles is equal to 180 degree. Okay, now we already know that one angle is 90, so second one it is even 90. So we can say that DBC is a right angle triangle. And from first congruency criteria, we can also say that AC is equal to BD, first third, first third. Okay, so AC is equal to BD, BC is a common side, one angle 90 degree. So by using side angles right criteria, we can say that triangle DBC congruent to ACB. And by using this simplicity, we can say that DC is equal to AB, right? Now DC means what? DM plus CM. Okay, so DM plus CM is equal to AB, and DM and CM both are equal. It is given, right? So 2CM is equal to AB, and finally transfer that 2 to the right hand side. So we get CM is equal to half of AB. Okay, so students, here our exercise 7.1 is complete. If you have any doubt, so please write down in comment section. I will give you the answer. Okay, thank you.